dear friends, welcome to GATE Academy Global. So before starting today's session, I would like to take the feedback as well as the concurrence regarding the audio as well as video quality. If it is perfect, just write perfect over the live chat, so at least I'll get to know that each and everything is properly transmitted from my side. My dear friends, as you can see over the thumbnail, in past 4 to 5 days, I was putting a lot of effort such that I must be able to plan a series in which with a minimal amount of the effort, the most of these streams would get benefited. And that is why it has been clearly written over here. It is a sort of majestic plan. And with the help of this majestic plan, almost all branch within the GATE stream would get benefited, which starts from the civil engineering, goes to the chemical, electrical, electronics, instrumentation, mechanical, as well as PI. Anyways, before going into the detailed analysis of this planning, like what are the different topics we are going to cover, which subject we are going to cover, how it's going to be benefited, how long it would be in span, in each day how much hour we are going to spend together. There are so many doubts would be there within your brain. There are so many different type of doubts you will be having within your mind. So that is what I have done. At very beginning, I will give you the little bit idea about the complete majestic plan which I had for you guys and how this majestic plan is going to help you a lot. Second thing, what are the different topics which we are going to cover? What would be the agenda behind this majestic plan? So there are several different doubts what we used to have. We are going to smash those all doubts point to point. Agreed what I am saying? See, the first slide goes like, at very beginning, the first doubt you will have in your mind, sir, which subject we are going to cover and what is your agenda? That is clearly written over this slide. We are going to mark the GATE engineering mathematics for year of 2022. But there are several ways to prepare the GATE engineering mathematics for marking 2022. But I would be learning the concept from the question which have come in GATE year of 2021. So what is my basic agenda? All of the questions which have come in the different streams, which starts from civil engineering, chemical, electronics, electrical, instrumentation, mechanical and production engineering. I have bifurcated all of the questions in a form of different topics. Like all of the questions in a form of a different topic. The first topic could be linear algebra. The second topic can be maxima and minima. Third topic can be differential equation. So at least one thing must be there in your mind. If I am saying, just a minute. If I am saying I am focusing over the GATE year of 2022 and the subject which I am focusing on is going to be the engineering mathematics. And yes, we will learn the concept from the questions which have already come in GATE year of 2021. Now the next thing comes to the mind, sir, which are the different branches would get benefited from this series of the videos? Almost all branch, which starts from the civil engineering, chemical, electronics, electrical, instrumentation, mechanical engineering, as well as production engineering. Next thing comes in a mind, sir, what are the different branches would be taken within the question which have appeared in year of 2021? Almost all branch. I have taken the questions from civil engineering. My dear friends, the civil engineering had the two sessions. First session was before afternoon and the second session was afternoon. Similarly, chemical had only one session, electronics has only one session, electrical had only one session, instrumentation had only one session, mechanical had again two session. First session and second session, and production had only one session. So how many number of papers we are going to discuss within the series of the GATE 2022 engineering mathematics? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 number of papers, and the questions which have appeared from the engineering mathematics are going to be discussed within this series. Agree? Till this point, each and everything must be clear to all of us. Next thing goes like, what about the timing? How much hour we are going to spend together in daily basis? How much time we are going to spend together in daily basis? Obviously, the time would remain same as we have been following so far. Yes. Precisely, our lecture would start at 9 p.m. and precisely will bind up around 10 p.m. So you can fix this time for me. The 1 hour we are going to spend together in daily basis, 1 hour, and the span of time would be from 9 p.m. to 10 p.m. 10 p.m. Yes. Probably what I have planned in daily basis, I would be taking 5 to 6 number of sums. 5 to 6 number of sums, and probably if I'll take 5 to 6 number of sums, obviously the 60 minutes would get over, and that would be the frame of time of the each and individual videos which are supposed to come in daily basis, Agreed? The next doubt would come in a mind, what it is, just a minute. And that's nothing but how many total number of questions which we are going to take within this series. My dear friends, total 64 number of questions have come if we include all of the branches and their all of the sessions. Total 64 number of questions we are going to discuss over this series. Obviously, all of the 64 number of questions we cannot discuss in a single day. That is what I have done. I have taken a fixed slot. In each day, approximately 5 to 6 number of questions we are going to discuss into the great detail, and probably within 12 to 13 days we would be able to cover all of the questions which have appeared in GATE 2021. And one of the best thing about it, what it is, the each and individual topic would be covered. What I am saying, I would be covering the each and individual questions within the topic. Like I would start from linear algebra from today onwards. What does that mean of it? That means all sort of the problem, either it have come in mechanical, civil, electrical, electronics, chemical, instrumentation, if they fall under the category of linear algebra, they would be taught at once. So what would be the benefit? The benefit would be slowly, sluggishly, you are going to cover the each and individual topic from the GATE 2021. And such a huge number of questions we have. And yes, if you have gone through this 64 number of questions thoroughly, conceptually, you would be able to crack almost all sort of problem conceptually. That is what I am saying. Although still I am taking the numerical, but with the help of numerical, we are going to learn so many new concepts, and probably the same concept would be utilized for your GATE 2022. Agreed? Till this point also, each and everything must be clear to all of us. The next thing comes, the branch who will get benefited. Obviously, you are from either of the branch. Either you are from civil engineering, chemical, electronics, electrical, instrumentation, mechanical engineering, or PI. Definitely it would get benefited. The next thing comes in mind, what it is? Just a minute. Period of this series. As I have communicated earlier, probably the 5 to 6 number of questions we are going to take in daily basis, and total 64 number of problems have appeared from the engineering mathematics if I include all of the branches which I have just shown. So probably I would be taking 12 to 13 number of days to smash this complete 64 number of problems. So the amount of days this series would last would be approximately 12 days. And once we are done with this 12 days, again I would come back with few of the important topics which has been left out, which starts from vector calculus, goes to random variable, random process, and ends to the complex variable. Agreed what I am saying? Anyways, let me move forward. Let me focus over the stats. What does it mean by these stats? How many number of questions have appeared from the engineering mathematics specifically in the different branches? If I start with the instrumentation, the 6 number of questions exclusively were found from the engineering mathematics. If I go ahead with the electrical engineering, exclusively the 7 number of questions were come from the engineering mathematics. If we discuss about the electronics, the 6 number of questions were exclusively found from the engineering mathematics, and the 2 questions were an ambiguous problem. Few of the teachers have kept within the electromagnetic theory, and the few of the teachers were kept within the engineering mathematics. But yes, lump sum, the 6 number of questions have appeared from the engineering mathematics. If you will go ahead with the civil engineering, you guys must be well aware of it. The civil engineering had the 2 sessions. In first session, 9 number of huge collection of the engineering mathematics have appeared in civil engineering. Not only that, if you will take the reference of its second session, there also the 9 number of questions have straight away appeared from the engineering mathematics. Yes. Similarly, if I take the reference of mechanical engineering, again the mechanical had the 2 sessions. The mechanical 1 had appeared the 6 number of questions from the engineering mathematics, and mechanical 2 or the paper 2, the 9 number of questions were appeared from the engineering mathematics, and similarly goes with the production engineering and chemical engineering. And one important point which has to be noticed, so far the weightage of the aptitude was prefixed. till GATE 2020. So 5 questions used to come for 1 marks, and similarly the remaining 5 questions were used to come from 2 marks, and the 15 marks were reserved for the aptitude. But the first time what they did, even they fixed the weightage of engineering mathematics to 13 marks. And now the next thing comes in mind, sir, whether they have followed this or not. See, IIT, what they say, it has been seen strictly they do not follow what they say. Like the syllabus, if you can see the syllabus of the electronics, they were saying the microprocessor has been ruled out, but still they have asked one question from the microprocessor. Even we had one question from closed line integration in Cauchy's integral form. There also they have done the mistake. So what we expect, whatever they say, strictly they do not follow. But once you'll analyze the each and individual paper, you will get to know approximately the weightage of the engineering mathematics was 13 marks. Approximately the weightage of the engineering mathematics was 13 marks in all of the branches. Somewhere it was 11 and somewhere it was 14, but yes, on average they have asked the question from the engineering mathematics had the weightage in between 11 to 14 marks. Now what happens? Why the engineering mathematics is so important? My dear friends, why the engineering mathematics is so important? Like you can take the reference of the branch electronics this year. The paper was quite difficult. So in that case what happens? Then scoring the good marks in your technical subject becomes very difficult. What I am saying? Scoring the good marks in your technical subject becomes very difficult. And if you are able to perform approximately 80% to 90% in your engineering mathematics, not only you will be getting the scorecard, you will be getting the good scorecard. Good scorecard. Could you understand what I am saying? So that is what I am saying. This is the second subject within your GATE examination where the marks distribution has been clearly written by the IIT body that they are going to ask the problem from the domain of the engineering mathematics, which would carry the weightage of somewhere 13 marks. And yes, they have been following it. And more importantly, if you'll see, the total marks carried by the GATE examination is 100, and now they have dedicated 13 marks to the engineering mathematics. That means 13% marks is supposed to come from the engineering mathematics. And I would say only one thing. If you are really thorough with the engineering mathematics, probably this is alone a subject where you would be able to score the 100% marks. The same case goes with the engineering mathematics, even in electronics. In few of the cases, deliberately, they have done the mistake. Otherwise, yes, the student can score the 100% marks in any of the situation, whether the paper is tougher inside, moderate inside, or simple inside. Yes. So till this point, each and everything must be clear to all of us. I would repeat what I intended for. So let me start from the first slide onward, and straight away we'll jump into the question. What I am saying? We are going to prepare for GATE 2022, obviously for the engineering mathematics. And what would be the basis for the preparation? I would be taking the reference of all of the questions which have appeared in GATE 2021. That's the first thing. What are the different branches I am going to cover? Obviously, I am going to cover almost all engineering branches. We start from civil engineering, chemical, electronics, electrical, instrumentation, mechanical, and PI. And even in civil as well as mechanical, we had the 2 number of sets within the GATE examination. I have taken all of the questions in a bunch, and I would be discussing all of the questions. That's the first thing. The second thing goes like, I could have taken this series in the different way. I could have started from the instrumentation. I could have taken its all problem. I could have gone to the electrical. I could have taken its all on problem, but this would not be the perfect way. Because whenever we prepare, we used to have one thought process in our mind. Sir, why don't we cover up a complete topic at once? Yes, I have done the same only. If I will be picking the linear algebra, I would be taking all of the questions from the linear algebra from either of these stream. Either it has come in civil, mechanical, chemical. Yes, so we would be covering each and individual topic to topic. Yes, and yes, if we'll talk about the timing, in each day we would be precisely meeting in between 9 to 10. Next, how many number of questions we are going to take? Total 64 number of questions have come if I consolidate all of the questions which have appeared in all of these streams, which I have figured it out over here. Yes. The next comes the branch who will be benefited. Obviously, all of the branches are going to be benefited. Yes, and periods of this series the 12 hours approx. 12 hours approx. Now here goes the weightage. So yes, I have done the few of the workout. How many questions have come from the individual branch? Yes. So anyways, without getting delayed, let me straight away go into the question and we'll try to solve it out. So here goes the question. And yes, from today onwards, we are going to start the first topic within the engineering mathematics, and that is nothing but linear algebra. So let me start from the first question onwards, and the first question comes from gate instrumentation, and by default, the year has been prefixed, and that's nothing but the year of 2021. Let me focus over this problem and find the determinant of this problem. Anyways, whenever I will show any sort of problem, probably I would be giving around 1 minute to solve by yourself. Once you're done with this, you can put your answer over the live chat. Tell me what would be the best most answer for this. This was the gate instrumentation year of 2021, and yes, the weightage was somewhere 1. Tell me what would be the best most answer. Anyways, for the better understanding what I would be doing, I would be bringing this problem into the working board and we'll try to solve there itself. Just a minute. Tell me what would be the best most answer for this given problem. Yes. This is the first question of the day. Obviously, the problem have come from the concept of the linear algebra. Tell me what would be the best most answer for this given problem. My dear friends, whenever you have a problem related to the determinant, what should be your approach? Try to find a row or column which contains the maximum number of zeros. That's for sure. And you can see very well, if you take the reference of the first row, the second row, the third row, the fourth row, almost they all are the semantic rows where the number of zeros are exactly 2. So you can take the reference of either of them. That's the first thing. Secondly, I would try to figure it out this problem in a different way. My dear friends, try to make linear relationship between either of the row or either of the column. What does that mean by the linear relationship? That means a certain constant multiplier of a certain row is framing the another row, or maybe a certain constant multiplier of a certain column is framing another column. If the linear relationship is being made, by default, the determinant would become 0. But here, the linear relationship is not made. Why? There cannot be any linear relationship between R1 and R3. Why? Because the element 0 and 0, if once gets multiplied with a certain constant, they cannot make 4 and 3. And similarly, there is no linear relationship between 1, 2, 0, 0 and 0, 0, 2, 1. That is for sure. Similarly, the same case goes with the 3, 4, 0, 0, 0, 0, 4, 3, 3, 4, 0, 0, 0, 0, 2, 1. Yes. That means one thing is quite sure. They are linearly independent. Agreed what I am saying? Only the dependency which you can make, that could be in between R1 and R2. But still they are not linearly dependent. If a certain constant is getting multiplied with first row, you will not be able to reciprocate the exact row once again. Like 1 can be made 3 by multiplying 3, but the 2 becomes 6. So definitely the row 1 and row 2 both are linearly independent. Similarly, the same case goes with the R3 as well as R4. If you wanted to make R3 same as R4, definitely 4 has to be bring to the 2. That means the 2 has to get divided with the third row again. The 4 have become 2, but 3 have become 3 by 2, which is not 1. Agreed what I am saying? So one thing is quite sure, whenever you have a problem related to the determinant, I would suggest always go ahead with a linear dependency between each of the rows and each of the columns. If they are linearly completely independent, definitely determinant can't be 0. So the 0 answer has been ruled out. Next. I would be choosing either of the row or either of the column where the number of zeros are maximum. Yes, I can choose the first row, second row, third row, fourth row. But I would suggest you could have applied one elementary operation. What it is? if R2 has been subtracted with the R1 with the appropriate fashion, definitely one of the element could have been made to 0, and there the calculation would become bit easier. So what I would be doing, either I can apply the elementary operation over the row 1 or maybe row 2. So here the operation which I am going to apply, it's the R2 tends to of, see, the 3 has to get smashed with the 1, and that's possible only and only if the 1 becomes 3 after multiplication of 3. So here it becomes R2 minus of 3 times of R1. 3 times of R1. Yes. So as such, there is no change in first row. It remains 1, 2, 0, 0. The 3 gets subtracted with the 3. The result would be 0. The 4 gets subtracted with the 6. The result becomes minus 2, and the remaining component remains as it is. Yes. Agreed what I am saying? So I would expect from each one of you, probably within 2 minutes you could have got this answer, because this problem is meant for getting the answer within 2 minutes. Till this point each and everything must be clear. So what I would be doing, I would be selecting a certain row or column which will have the maximum number of zeros. Obviously I can select the second row which had only and only one non-zero component, and the remaining components are 0. Now if I'll take its determinant, obviously I will leave its complete row, I will leave its complete column. And the place of minus 2 is positive in nature. How? Because it has been placed in the second row, in the second column. So the weightage of minus 2 would be plus, minus 1 to the power of 2 plus 2. Here goes minus of 2, here goes minus of 2. You have to leave the complete column, complete row. The factor which will be left out is simply going to be 1, 0, 0, 1, 0, 0. You have to leave this row. Here goes 0, 4, 3, here goes 0, 4, 3, and here goes 0, 2, 1, 0, 2, 1. 0 to 1. Yes. Now here what's going to be outcome? Minus 1 to the power of 4. That's obviously plus of 1. Plus of 1 is getting multiplied with the minus 2. The result would be minus 2. The same process would be followed over here also. Always whenever you go ahead with the determinant, try to search the row or column where the maximum number of zeros are present. I can take the reference of the first row itself. May I know the 1 is being placed in which weightage, whether it is in weightage of positive or whether it is weightage of negative? Obviously it is being placed in first row, first column. So here it's going to be minus 1 to the power of even value. Obviously weightage would be plus, so it would be plus 1. And now again you would be having 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1. Tell me what would be the answer over here. So minus 2 gets multiplied with 1, that's simply minus 2. Yes sir, it's a minus 2. And here the 4 gets multiplied with the 6, that's nothing but the minus 2. The result what we get, it's simply going to be plus 4. The result what we get, it's simply going to be plus 4. Till this point each and everything must be clear to all of us. Yes. And this was the problem where simply I need to get the determinant, and the problem was framed in such, if you would have applied an elementary operation, then you could have solved this problem into the minimal amount of steps. Yes. And the determinant can't be 0 because they are linearly independent. All of the rows, all of the columns are linearly independent. Till this moment of point each and everything must be clear to all of us. Now what I would be doing, I would be taking a sort trick. You can write over the copy, sort trick. Now if you have been dealing with a matrix, let's take in order of 3 cross 3, and their elements are, let's take 1, 2, 3, 3, 1, 2, 1, 1 and 0, 1, 1 and 0. And I wanted to calculate its determinant. Let's take it is a matrix A. I need to calculate the determinant of the matrix A. See, as far as this matrix is concerned, it is a tedious matrix because the number of zeros within this matrix is absolute. There is no zero at all. So the calculation becomes a bit difficult. So what the people do? Straight away they will be applying a certain elementary operation and they will try to make the maximum number of zeros. But once you go through that process, definitely it becomes a lengthier process. May I know, if you have a matrix of a 3 cross 3, what would be the sort trick for getting the determinant of this matrix? You can apply a sort trick method. See what it is. You can keep that matrix as it is, and now the starting 2 column you can repeat once again. See what I am saying? It is 1, it is 2, it is 3. It is 3, it is 1, it is 2, it is 1, 1 and 0. You can repeat this starting 2 column once again. That's nothing but this. Now what you will be doing? You would be going for the forward multiplication minus of backward multiplication. What does that mean by the forward multiplication, my dear friends? It is the forward multiplication. How many times the forward multiplication would be done? In case of 3 cross 3 matrix, 3 times. So once you multiply 1, 1 and 0, obviously the result which comes in my hand is simply going to be 0. Here goes 2 into 2 into 2, that's a 4. Obviously it becomes 4 now. It becomes 4 now. Similarly 3 3 is 9 into 1, that's a simply 9 now. Minus of backward multiplication. Backward multiplication. How many times the backward multiplication would take place? As we had 3 times forward multiplication, backward multiplication would also take place 3 times. Let me change the color a bit. So here goes the first, here goes the second, here goes the third. Anyways, let me multiply 2, 3, 0. You need not to multiply 2, 3. Once it gets multiplied with the 0, the result is simply going to be 0. The 1 gets multiplied with the 2, that's a 2 into 1. Again, it's a 1. And here it goes 3. 3. Agreed what I'm saying? So 4 plus 9, that's a 13. 13 minus of 4. 13 minus of 4. Simply the result is going to be 9. Simply the result is going to be 9. So I would request to each one of you, the student who are dealing with a certain square matrix with the order of 3 cross 3 and they wanted to get its determinant, and where the matrix does not have much element where the elements are 0, so simply they can take this route and easily they would get the answer, which is nothing but the determinant. Yes. So let me move forward. Let me move into the second question. Tell me, what would be the best most answer for this given problem? Let me read the problem carefully. Question 2, given A is equals to, it's a square matrix with the order of 2 cross 2, 2, 5, 0, 3. The value of the determinant mod of a to the power of 4 minus of 5 into a to the power of 3 plus of 6a square plus of 2i would be approximately. Anyways, it was a type of NAT. That means you had to feed the answer through the mouse. Tell me what would be the best most answer for this given problem. So let me copy this problem out over here and bring it to the working board. Tell me what would be the best most answer for this given problem. Again, this problem have come in gate instrumentation year of 2011, 2021. Tell me. Tell me, what would be the best most answer? What would be the best most answer? Tell me. Tell me what would be the best most answer. And again, this problem has appeared in gate instrumentation year of 2021. Year of 2021. Probably few of the mistakes the people are saying. We'll see that. Anyways, focus over the second question. Where I need to get the determinant of a new polynomial which are made with the help of a, which is a to the power of 4 minus of 5, a to the power of 3 plus of 6a square plus of 2i. I wanted to get the answer from each one of you. And specifically, I would want the answer from the student who are not from the instrumentation background, because this question was a question where the major of the student have done the silly mistake. Tell me what would be the best most answer. My dear friends, you yourself would be able to see it is a square matrix with the order of 2 cross 2. A is a square matrix with the order of 2 cross 2. And now if you wanted to get the determinant of this polynomial, first you had to calculate a to the power of 4. What does it mean by the a to the power of 4? That means the matrix A has to get multiplied 4 times. Similarly 3 times, similarly 2 times, and here it is identity matrix, which is not that easy. So may I know what must be your approach? My approach must be to reduce the degree of this polynomial. It is in a degree of 4. If it is being reduced to degree of 2 or 1 now, obviously calculation would become much easy. Anyways, how the reduction in their degree can be taken place? Obviously with the help of Kelly-Hamilton. So I would be using the method of Kelly-Hamilton. What the Kelly-Hamilton says? all of the characteristic equation of a certain square matrix satisfy its own matrix. What does that mean of it? First, we had to focus over its characteristic equation. How the characteristic equation of a certain matrix can be calculated? Let's take, if you have a matrix A and you had to get its characteristic equation, you had to find a matrix A minus of lambda I, where the I is nothing but the identity, and similarly lambda is nothing but the eigenvalue. You had to take its determinant, and now you had to get compared with 0. Now you had to get compared with 0. So obviously the 2 gets subtracted with the lambda, 5 would remain as it is, 0 would remain as it is, 3 would get subtracted with the lambda. So here the result what we had in our hand is simply going to be 2 minus of lambda, here goes 5, here goes 0, here goes 3 minus of lambda, and yes, after taking its determinant we had to get compare with 0. We had to get compare with 0. And now I would expect from each one of you, without doing much of the mistake, straight away you must be able to get the polynomial out of this. See, 2 is getting multiplied with 3, so obviously the constant which will be coming out is simply going to be 6. Minus lambda gets multiplied, it would become plus of lambda. There 2 of minus lambda would become minus of 2 lambda. Minus of lambda is getting multiplied with 3, that would become minus of 3 lambda. Put together it becomes minus of 5 lambda. So straight away I am going to write the characteristic equation, which is lambda square minus of 5 of lambda minus of 5 of lambda, and here goes 6, and that is equals to 0. And as per the Cayley-Hamilton, the characteristic equation has the function of lambda. If the lambda is replaced with its own matrix A, still the equation would be satisfied. So obviously, rather writing it lambda square, I may write it 5a square minus of 5 of a. And keep in mind, so far we were dealing with the lambda, where the lambda was eigenvalue, but now we have been dealing with the matrix A. So obviously the 6 has to get multiplied with a identity matrix, which is nothing but the 6 of 5. So one thing must be there in your mind: it's a matrix, and even 0 is nothing but a type of null matrix. Yes. Anyways, I want to get the answer from each one of you. Probably 16 number of concurrent viewers are there over the live chat, and only 2 answers I have got it so far. I want more number of answers. Tell me what would be the best most answer for this given problem. My dear friends, I would be using the same matrix once again. That is nothing but a to the power of 4 minus of 5a cube plus of 6a square plus of 2i. If I take a square common, so the factor which being left out is simply going to be a square minus of 5 of a plus of 6 of I, and here the factor which is left out is simply going to be 2 of I. And you yourself would be able to understand the a square minus of 5a plus of 6i is equals to of null matrix, and if the null matrix gets multiplied with any of the corresponding matrix, the result would be a null matrix. So here the result what we get, the null matrix getting added with the identity matrix getting multiplied with 2, the result would be 2 of I. That means if you are supposed to calculate the determinant of this 4th degree polynomial, straight away you can calculate the determinant of 2 of I. Yes, I have seen, but still many of the students do mistakes over here. May I know what used to be the determinant of 2 of I? Many of the students would say it's just simply 2. And yes, I have seen in this year many of the students have simply written this as 2. No, it's not like that. It solely depends on the order of I. You try by yourself. Let's take the I is a square matrix with the order of 1 cross 1. That means it would be simply 2 with the matrix of 1. That means it's a matrix of 2. And once you will take its determinant, the result is simply going to be 2. And let's take, if I is identity matrix with the order of 2. So how many number of rows, how many number of columns you will be having? 2 number of rows as well as 2 number of columns you will be having. And whenever we talk about a constant multiplication with a matrix, the multiplication takes place with each and individual terms. That means the 1 becomes 2, 0 remains 0, 0 remains 0, the 1 becomes 2. Put together, I need to get the determinant of 2, 0, 0 and 2. How many times the 2 would be taken out? Either you can take the difference of column or rows. If you take the difference of row, the 2 would be coming out, So it would simply become 2 to the power of 2, 1, 0, 0 and 1, and its determinant is 1 getting multiplied with 4. The result is simply going to be 4. Agreed what I am saying? Now even this problem, let's take this problem is still framing the same type of polynomial, and if the order is 3 cross 3. Yes. The problem could have been framed in the different way. Rather taking the reference of 2 cross 2 matrix, they could have taken the reference of 3 cross 3 matrix, and they could have asked the value of this. In that case, the situation would be, it would be 2 of I, and now I is identity matrix with the order of 3 cross 3. So how many times the 2 would come out? The 3 times the 2 would come out, and simply the result would be 8. The result would be 8. Yes. So one of the important point we can write over here, usually most of us must be knowing it. If you have a matrix alpha times of A, and if you are seeking its determinant would be alpha to the power of n into the determinant of A, where n is the order of square matrix. Yes, till this moment of point, each and everything must be clear to all of us. Now it's right time to go into the next question. See, here comes the next question. This problem have appeared in GATE Electrical, year of 2021. Tell me what would be the best most answer for this given problem. Let me read the problem thoroughly. Let P and Q be real numbers, they are real numbers, such that the P square plus of Q square is equals to 1. That means the P and Q together satisfies this equation. The given value of the matrix PQ, Q minus of P, it's a square matrix of the order of 2 cross 2 R. The options are given as 1 and minus 1, PQ and minus PQ, 1 and 1, J and minus J. Tell me what would be the best most answer for this given problem. And this was the question for the 1 mark, which has appeared recently in GATE Electrical. So let me do one thing. Let me bring this problem into the working board. Tell me what would be the best most answer for this given problem. And this sort of problem are repeatedly coming in GATE examination, where I need to connect the eigenvalues with P and Q. Yes. The student is stating, the can aeronautical engineering student follow this course? Obviously yes, my dear friends. Obviously yes. The syllabus of the aeronautical engineering is not very different in engineering mathematics. Definitely it's going to help you a lot. So obviously you can take the reference of this session and at the same time the sessions which are supposed to come in addition with this session. Tell me what would be the best most answer. My dear friends, what are the datas are being given along with this problem? The first data, the P and Q which has been used within the matrix of a 2 cross 2 had been maintaining a certain relationship, which is nothing but the P square plus of Q square is equals to of 1. P square plus of Q square is equals to of 1. If I am taking the reference of this relationship, few of the options can be ruled out. See, we'll see. Okay, no issue. Now, if you take the reference of that square matrix, P, Q minus P, how many number of eigenvalues you will be having? The number of eigenvalues is simply depending on the number of or the order of system. So order of this system is nothing but the 2 cross 2. So how many number of eigenvalues you will be having? 2 number of eigenvalues you will be having. For the time being, you may mark them as a lambda 1 and lambda 2. And as per the property of the matrix, you know the multiplication between their eigenvalues is simply equals to of the determinant of the matrix. And if you calculate the determinant of the matrix, it becomes P of minus P, that is a minus P square, minus of Q square. So obviously the minus can be taken out. It simply becomes P square plus of Q square. And the P square plus of Q square has been clearly given, which is equals to of minus 1. What does that mean of it? That means with the help of the property, followed by the eigenvalues of any of these square matrix, and at the same time the relationship between the P and Q, I got one relationship, and that's nothing but the lambda 1 into lambda 2 is found to be minus 1. So what are the datas can be ruled out? Obviously C can be ruled out. Even if you multiply J and minus J, this would also be ruled out. When the multiplication between J and minus J takes place, J becomes J square, that is nothing but the minus 1. Minus 1 gets multiplied with the minus, obviously it would become plus 1. Obviously this is also ruled out. So the best most answer which has been left out is simply going to be 1 and minus 1. Even you can cross check even further. How? So for only one property has been used for the eigenvalues, which is nothing but their multiplication. Even you must be knowing their properties in terms of their addition. What does that mean of it? The two possible eigenvalues what we have, their addition would be very same as the truss of the given matrix. What is that? The truss of the given matrix is nothing but the addition of its all possible main diagonal elements, which is nothing but p minus of p, which is simply 0. And you can see very well, even A is again satisfying that requirement. A is again satisfying that requirement. Agreed what I am saying? A is again satisfying that requirement. So this was the question 3, and the best most answer was option A. Option A. So let me move forward and go into the next question. Here goes the question number 4. Let me take the screenshot and bring it to the working board. Here goes the question number 4. Tell me what would be the best most answer for this given problem. Here goes the question number 4. Tell me what would be the best most answer for this given problem. Anyways, read this problem carefully and then we'll try to decode this problem out. Let A be a 10 cross 10 matrix such that A to the power of 5 is a null matrix. Yes. May I know, if we take the reference of A to the power of 5, which has been given as the null matrix, what would be the order of it? Obviously the order would be 10 cross 10. See what is happening over here. If you have a matrix A which is an order of 2 cross 2, if you will find A square, that would also be an order of 2 cross 2, A cube would also be an order of 2 cross 2, and the same concept prevails. The same thing goes with 10 cross 10. If you have a matrix of A 10 cross 10, A square would also be 10 cross 10, A to the power of 3 would also be 10 cross 10, and A to the power of n, where the n is any natural number, would also be in order of 10 cross 10. Yes. Agreed what I am saying? So anyways, you can write the data which has been given along with this problem is A to the power of 5 is a null matrix, obviously in order of 10 cross 10. In order of 10 cross 10. And let I be the 10 cross 10 identity matrix. Yes, it has to be, my dear friends. If A and I has to get added, no, obviously their order has to be very same. So what is I over here? The I is nothing but identity matrix, and again the order of the identity matrix is 10 cross 10. Order of the identity matrix, there is a problem in visible, the question. Just a minute. I may increase a bit. Yes. Probably it must be visible now. Yes. So here goes I of 10 of 10. You need to get the determinant of the matrix. Now as per the problem, you need to get the determinant of the matrix A plus I. Tell me what would be the best most answer for this given problem. So probably the question must be clearly visible over the blackboard, and now we need to get the determinant of the mod of A plus of I. Tell me what would be the best most answer. My dear friends, if A to the power 5 is a null matrix, what I would do, I would multiply A inverse both other side. A inverse is also a matrix. If I apply A inverse both other side, it becomes A inverse into A to the power of 5. Towards right hand side, it's gonna be A inverse into a null matrix. The multiplication between a non-null matrix and null matrix would always be a null matrix. So from here I can conclude A to the power of 4 would also be a null matrix. Yes. Not only that, if I multiply A inverse both other side, so here it becomes A cube, A to the power of 2, A. End of the day, even you can say the matrix A is also a null matrix. Yes, matrix A is also a null matrix. So obviously you can take the reference of this determinant. The A is gonna be a null matrix and I is gonna be identity matrix with the order of 10 cross 10. So once we'll add them together, the result would be identity matrix with the order of 10 cross 10. And once we'll take its determinant, the result is simply gonna be 1. So as far as this problem is concerned, the best most answer for this given problem was simply 1. Agreed? No? So now it's right time to move forward, taking the next question. And yes, this was the problem where a bit aptitudinal mind has to be applied, and it may take a bit longer time. It may take a bit longer time. Anyways, when this problem has been appeared, it has been appeared recently over the GATE Electronics year of 2021. Let me read the problem carefully and we'll try to decode the problem out, how this problem can be smashed out. See, a real 2 cross 2 non-singular matrix. What does it mean by the non-singular matrix? That means in future, once you will be feeding the value of x and once you will take its determinant, the determinant has to be non-zero. With repeated eigenvalues is given by. See how many times the problem have come from the concept of the eigenvalues and eigenvectors. Yes, it has been a pure class problem and the problem used to come repeatedly from this domain. Similarly, where x is a real positive number, the value of x rounded off to the 2 decimal place is. With this given data, you had to find the value of x. So again, what I would be doing, I would be bringing this problem into the working board. Yes, here goes the problem. Here goes the problem. Tell me what would be the best most answer for this given problem. Tell me what would be the best most answer for this given problem. Anyways, let me focus over the problem. Solution. See, it has been clearly given the matrix A is a non-singular matrix. That means in future, after feeding the value of x, if I get the determinant of A, it has to be a non-zero value. That's the first thing. A with the repeated eigenvalues. My dear friends, if A has the order of 2 cross 2, how many number of eigenvalues you will be having? Obviously, the 2 number of eigenvalues you'll have. Let's take the first one is lambda 1 and the second one is lambda 2. But as per the given information, both are repeated. So rather writing it lambda 1 and lambda 2, straight away I would be writing them as lambda and lambda. As such, there is no bifurcations between them as per the given information. Next, it has been clearly given the matrix A for which the eigenvalues were wrote as lambda and lambda, which is nothing but A is equals to x minus 3 plus 3, 4. Rather writing it 3.0, 4.0 minus 3.0, I would be happy to write this as minus 3 plus 3 and plus 4. Why? Because the writing effort would be reduced and the reduced form of the calculation would always be leading a correct answer. Now, so here the matrix A comes as x minus 3, here goes plus 3 and here goes plus 4. Yes. Now, my basic intention is to get the value of x. Tell me, how will I get the value of x now? And any of us would be able to calculate what is the exact answer for this particular question. You can reply over the live chat. Tell me, my dear friends. Again, the same property I would be using which I have used in the last problem. What it is? The additions of their all possible eigenvalues. How many possible eigenvalues we had? 2 possible values we had, and both of them were equal. That means we can write lambda plus of lambda. And the addition between all possible eigenvalues is very same as the trace of the given square matrix, and that's nothing but their addition of their principal diagonal element, which starts from x land up to 4. So here the result which comes out to be, yes, 2 lambda is equals to of x plus 4. And now the lambda can be written in a form of x, which is nothing but lambda is equals to x plus 4 divided by 2. Yes. Now the another relationship between lambdas and the determinant of the corresponding matrix can be used. What it is? The multiplication between their lambdas. Both of the lambdas are repeated. That means the lambda 1 can be written as lambda 2 can be written as lambda. Their multiplication has to be very same as the determinant of this matrix. What it is? It's a 4 of x plus of 9. Yes. Lambda and lambda becomes lambda square. The lambda is known to be x plus 4. Yes, x plus 4 to the power of 2, and here you will be getting the value of x now. Tell me what would be the best most answer. My dear friends, first I'll take the square. If I'll take the square, it would become x of square plus of 16 plus of 8 of x divided by a 4 gets multiplied towards right hand side. It would become 16 of x and it would be a plus of 36. it would be a plus of 36. Yes, what I would be doing over here, let me bring all of the RHS towards left hand side. So the factor which will be left out is simply going to be 8x gets subtracted with the 16 of x, it would become minus of 8 of x, and similarly minus of 20, minus of 20, minus of 20. Yes. So anyways, two answers you would be getting. First is going to be positive answer and the second is going to be negative answer. You yourself would be able to get this value. No? You yourself would be able to get this value. So the best most answer or the positive best most answer what we are getting after solving this quadratic equation is simply going to be plus 10. After solving this quadratic equation is plus 10. This was a well crafted problem. I cannot say it was a difficult problem, but yes, within a frame of 3 hours, where you had to attempt all of your problems, where the problem do come from the various segments, various topics, various subject. Usually this sort of problem becomes a still mark during the period of GATE, and mostly a student may not be able to get this value. The answer is going to be plus 10. The answer is going to be plus 10. Yes. So now comes the last question of the day. Now comes the last question of the day. If the vector 1, minus 1, 2, 7, 3, x, 2, 3, 1 in 3D space of R cube are linearly dependent, the value of x is. I need to get the value of x. Again, you had to find the value of x now. Tell me, my dear friends, if this 3 numbers which has been enclosed within a small bracket has been taken a vector, what does that mean of it? Either in future they can be made as a column listing over a matrix, either they can be made as a row listing over a matrix. And keep in mind, if the vectors are linearly dependent, that means in future within the matrix their rows or column would be linearly dependent. If either of the row or either of the column becomes linearly dependent, what does that mean of it? That means whenever you calculate the determinant of that corresponding matrix, the result has to be 0. So what I would be doing over here, I would be crafting a determinant by using 1, minus 1, 2. You can keep into form of column or either you can keep it to in the form of row. So obviously you can choose either of them. Here becomes 1, here becomes minus 1, here becomes 2, here goes 7, here goes 3, here goes x, here goes 2, here goes 3, here goes 1. And as I have been telling earlier, whenever you have the problem related to the determinant of 3 cross 3, the best method is the short trick method. You can repeat the starting 2 columns. Yes, I would be repeating over here. So I can do one thing, I can rub this out. So here it becomes 1, 7, 2, minus 1, 3, 3. So here there would be a forward multiplication. How many times? 3 times. So 3 gets multiplied with a 1 and 1, simply it would be 3. Similarly, x gets multiplied with a 2, that would become 2 of x, minus of 1, that would become minus of 2x. Minus of 2x. Yes. Similarly, 7 goes multiplied with a 3, that will become 21. 21 would get multiplied with 2, that would become 42. That would become 42. Now you would be taking the backward multiplication. You would be taking the backward multiplication. How many? 3 backward multiplication has to be taken place. What are they? You can see very well. This is the first backward, this is the second backward, this is the third backward. So 7 gets multiplied with a minus 1 would be resulting minus 7. Minus 7 gets multiplied with 1. Obviously it would be minus 7. Here goes the x gets multiplied with the 3, that's the 3 of x gets multiplied with 1, remains 3 of x. Remains 3 of x. Similarly, here the 3 gets multiplied with 2, that's the 6 plus 2. That's 12. That's 12. And has to be equals to 0. Has to be equals to 0. The same procedure has to be used. My dear friends, the 3 and 42 would become 45. Minus of 2 of x. Minus would be kept as it is. 12 minus of 7, that's a 5. And it would be is equals to 0. Is equals to 0. So what is happening over here? It's a minus of 5 only, no? It's a minus of 5 only. Yes, it's a 5 only. Yes. So do one thing, open this bracket out and try to get the value of x now. Try to get the value of x now. So what I would be doing over here, minus 2x minus 3x, that would become minus of 5x. Minus of 5x. Yes, minus of 5x. And similarly, 45, the result, tell me what's going to be the result out of this. What's going to be the result out of this? So the result what we are getting now. So here it's going to be minus 5x plus of 40 is equals to 0. So here it becomes 40 divided by 5. The result is simply going to be 8. the result is simply gonna be 8. And if you do not know this sort trick, no, probably you will take hell amount of calculation just to get this determinant. I know that. Because I have seen many of the times the students are well acquainted if the number of zeros within the matrix are so high. So what they would do, they would select either of the row, either of the column where the number of zeros are more, and they'll try to get that determinant. But if you have been dealing with a certain matrix where the number of zeros are minimal, the calculation of the determinant becomes very difficult. So I would suggest to each one of you, better to use this sort trick. And once you will be using, or once you will be solving a 2 or 3 number of questions using the sort trick, no, probably you would be well acquainted with this calculation or this methodology. So how many number of questions we have taken in today's class? The 6th number of questions we have taken in today's class. So probably I could cover the question from the linear algebra which have come in electrical, instrumentation as well as electronics. Anyways, tomorrow I would proceed from here onwards, and again I would be taking the remaining question which have come in GATE, obviously mechanical, civil, from the topic called linear algebra. We'll meet tomorrow precisely at same time, 9 p.m. Thank you. Thanks a lot.